Hello, hello, hello. Okay, ma'am, start with it.
Thank you. Sir, we have start our program now, sir.
Yes. So can I? Okay, let me present the slides then.
Sir,
Okay,
let me
yeah.
do some introductory part for you. Then you can present your slides.
Uh,
A very small
I don't think
introduction.
that
A very
this
small
needs.
introduction, sir.
There is nothing. Okay, I can make the self introduction in that sense. Okay, if somebody likes to
Sir,
take that.
give us that opportunity to
No.
introduce you in
If
our.
some of your colleague or students like to take this pen, it's okay, fine. But
Yes,
I don't
yes,
think
yes,
it's
of
not.
course, sir, of course.
Yes.
So a very good
Okay.
afternoon to everybody and our honorable speaker, Professor Santi Prasad Maity from IEST, and all the participants present over here for these webinars. I would like to ask our assistant professor from Computer Science and Engineering, Brainware University Department, Priyanka Ghosh, to introduce Sir with all of us. Thank you.
I don't know how she got she information, but if she gets information, Professor Ghosh, if you get information from website, please make concise. That we need to write just for other region. So please concise.
Okay, sir, I will try.
Uh,
Thank you, Devdatta madam. Good afternoon, everyone, for joining us in this interactive session. Today, we are lucky to have Dr. Santi Prasad Maity as our guest speaker. I would like to take this opportunity to introduce Dr. Maity to you. Dr. Maity is a present professor in the Department of Information Technology, IIEST, Shibpur. He received his BE degree in Electronics and Communication Engineering from National Institute of Technology, Durgapur, and MTech in Microwave from the University of Burdwan in 1993 and 1997, respectively. He received his PhD degree in engineering with the thesis title Studies on Data Hiding in Digital Media for Secure Communication, Authentication, and Content Integrity from the IIEST. He received a couple of postdoctoral research positions from the different institutes like NTU, Singapore, University of Vigo, Spain, etc. He did his postdoctoral in France. He is having more than 24 years in teaching experience at different academic institutes. He has research interest in diverse fields, include quantitative radio, cooperative spectral sensing, joint spectral sensing and secondary transmission, security, energy harvesting, digital image watermarking and secret sharing, machine learning and deep learning in medical image processing, and many more. He has published more than 280 research papers in international journals. So it is an honor to have you with us, sir. We are all extremely excited to attend your session. Now I would like to invite Dr. Maity to take the stage. Thank you so much, sir. Sir, over to you.
Thank you, Professor Ghosh. Very good afternoon to all, and thank you, Professor Dotto, Professor Paul, for inviting me to deliver this talk. Let me first share the screen. Uh, can you see the slide?
Yes, sir.
Okay. So, I don't know, maybe the bandwidth. So let me first make this one. Okay. So, good afternoon to all. Uh, it's indeed my pleasure to deliver this talk. I like to thank Professor Paul for inviting me to deliver this lecture. When she invited me to deliver this talk, really I was hesitating uh, because the audience are from the computer science backgrounds, and the topics that I will be talking about is the very these days they are very, becomes the core of their heart, particularly the undergraduate and postgraduate students. So I was really feeling uneasy to deliver on this kind of topic. But still, my objective here is not to teach you about, though it is written like this title, uh, Introduction to Recent Trends, but my whole objective is to share and to tell you something that during our learning process, if we think with our day-to-day fact, or we like to make an analogy, or if when we study one course and if we make an analogy with respect to the other, possibly our learning to be enriched, and we can make that model in solving many of the problems. So that's my objective. I like to share that how an particular type of method or algorithms can cater to three different engineering problem, as long as the problem looks similar, or if you can make your problem similar like. So apparently looking two different objective or two different fields, how a single algorithm or similar algorithm can be made use. So that's my objective of that's the only objective possibly for this talk. Otherwise, as far as the technical content is concerned, I believe that the audience, the faculty member of the computer science engineering, and the students of undergraduate and PG gets know much better than me about the machine learning and all this. Okay, so outline of this talk, I will just briefly talk about machine learning and deep learning. Then I will be talking about deep learning, convolution neural network. My whole objective is not to talk how convolution, what are the different types as layers of convolution layer, what do they do, not in that elaborate form. I just touch upon and how a convolution neural network, where to use, because uh, there is a tendency among the research community for solving any kind of problem these days use couple of deep learning network, like say recurrent neural network, convolution neural network, without understanding or sometimes without bothering their relevance or justification of using that algorithms in that particular research problem or not. In that context, I will talk about, in all cases, one or two slides. So my talk will consider the application and medical image application, like say melanoma detection for convolution neural network framework. Then we will talk about generative adversarial network or GAN network. Understanding of GAN I will little bit say. Then an application perspective, one of our own work, like say for melanoma detection, this is our own work. Similarly, I will be talking when GAN networks, particularly the super GAN, a form of autoencoder model of convolution neural network, from low resolution to high resolution image. Then I'll be talking bit operation of reinforcement learning, and this reinforcement learning I'll talk about in different application framework, like channel allocation in multi-hop routing, and again similar kind of algorithm that we develop, how one can make use in an intelligent transport system problem. We'll be talking about the security approaches, wireless security, and how this wireless security framework again can be extended in IoT healthcare application. So reinforcement learning, I will after introduction talk about different applications and how a model can be tuned or how it can be just a bit change for catering diverse application fields. And then I will be talking about the challenges and application of these different network, particularly the GAN networks and the reinforcement learning network. Now, the first question that definitely comes, why machine learning, and where the machine learning to be used? Well, there are a couple of words the engineering students are really enlightened with these words, like 5G, IoT, big data, cloud computing. So 5G, there are different, if there were any scope, I could have been more interested to talk about 5G, because that's my area of interest as communication. But all we know that the promise and the potential of 5G, one we say high data rate transmissions and huge or large volume of data. It is expected that 40 terabytes of data to be used by a user per month. So high data rate and huge volume or large volume of data, that's one of the promise of 5G. IoT, when we talk about, it says that there are billions of wireless nodes to be connected worldwide, and they will share data. They will have continuous communication among themselves. So there are scarcity of spectrum. Allocation of the channel is an important issue. How this radio spectrum, which is a scarce resources, limited resources, irrespective of the domain, whether you are a communication people, you are having a constraints or limitation on the channel. When you are a computer science people, you are to work with limited resources of memory, computation power, and all this. So in a resource constrained environment, we have to work with. And in IoT, there are wireless nodes. These nodes are battery driven mostly. They are having limited power, and they also have limited memory. So how this, but it's true that when billions of nodes to be connected worldwide, they will handle huge amount of data. So there are emergence of data sciences. Data science, what does it like to mean? It's a multidisciplinary uh, field involving system, methods, and algorithms that works on structured or unstructured data to understand where this information or the data come from, what does it mean, how they can be transferred into an useful resources so that strategies for information technology to be defined. So all the computer science people, you know that there are buzzwords again coming this data science and this data. So what I'm going to say that there are data centric operations, and this data centric operation I like to means that there are data acquisition or data capturing, data storage, efficient storage, data presentation, data manipulation or processing, transmission, prediction, modeling, and interpretation. Prediction, modeling, interpretation is the I words for the computer science people, particularly handling huge volume of data. So when I talk about the data science, in fact, there are two contradictory situations. In one hand, I am telling the big data, huge volume of data, their modeling, analysis, and interpretation, predictions are very important. And at the same time, we will also face the scarcity of data, particularly in the field of medical, particularly in the field of military communications or security aspects, where because of many regions, say for authentication purposes, even if there are a country like India, huge populations, and there are a large number of patients, maybe huge numbers, but still this medical data not easily available for the researchers because of the ethical purposes and others. So when you are a researcher, you will be working on medical field, you need to face the challenges of scarcity of data, and you need to go for data augmentation or data generation, data synthetic data generation, and this is the thing. But over and above either the situations, our whole objective is to design an intelligent systems, and there is the needs of machine learning. If we again look back, the driving force is the computer. The birth of digital computer has introduced a machine that's shown its superior capability for processing numerical data than human being. So what I'm going to say that computer is more capable than human being for processing numerical data. And that brings a pertinent question. Is it possible to mimic the way human interpret non-numerical data? Why non-numerical data? Now, much of the information that human being capture from the society or environment are non-numeric in nature. For example, image, video, text, message, or speech, music, humidity, temperature, all these are data mostly non-numeric. So question comes, if computer shows efficiency than human being for processing numerical data, is it possible that computer will show similar or superior performance than human being for processing this non-numerical data? And that gives us a couple of subjects or fields, research fields like pattern recognition, image processing, computer vision, artificial intelligence. Means our whole objective, the way human interpret, perceive, analyze non-numerical data, the machine will also do like that way. So some form of mimicking intelligence inside a computer gives birth the subjects artificial intelligence. And from there, a sub-branch of artificial intelligence is the machine learning or machine intelligence. By machine learning, what we like to means that the machine will have the intelligence like the human being, or machine will learn like the way human learn. Remember our very childhood when we come, were very early days or early stage, I mean early stage of our 1 or 2 years, we learn lots from our parents by going through different types of patterns. So it's something like that learning, I mean intelligence requires knowledge, and knowledge to be achieved by means of learning. So what I'm going to say in the context of machine learning is that we have to learn or gather knowledge. Talk no, I mean we have to gather knowledge from the through the learning process, and that to be done by exploring the environment of the nature. So in the context of machine or in the context of computer, we have to impart this knowledge or learning inside a computer, and that's basically the machine learning or machine intelligence. So machine intelligence or machine learning wants to means that mimicking or incorporating some form of knowledge inside a machine, imparting knowledge inside a machine. Now the typical question that comes, that computer I mean the traditional approaches of AI and that of the machine learning is that when you run a program in a computer, the computer works on the rule basis. There are some conditions imposed, and based on that conditions, it produces some output when you run an algorithms. But in machine learning, we do not have that scope of explicit programming. That means what it like to means that explicit programming. That means it doesn't like to work on the real rule basis. It does not work on some guidelines that to be fed like the way we run computer programs. So there is the difference. Often we might have a question that what does it like to means that without going for explicit programming, the machine learning, it like to means in that the data to be huge amount of data to be fed, and computer will learn the hidden pattern or the model inside the computer, and that model to be used in prediction in future course of time. So what I like to mean is that computer is fed to huge amount of data to learn automatically and then improves from the experience. So one sense you can say learning from and predicting on data. That's basically the machine learning, which I'm going to say in the next slide. But prior to that, I need to say that we must have to understand when and where we will do machine learning. So, means not in all problem we will be tempted to apply machine learning algorithms. Where to, so algorithms, as I say, algorithms has certain characteristics, like it takes certain input and under certain instruction it produces certain output. This instruction has certain again criteria like finiteness, preciseness, and all this. I'm not going to that part. But if we think of the perspective of a system, so system implies or means a kind of mapping from input to output. That sort of things I'm going to say in order to understand why to use machine learning. So a systems that are responsible for mapping a set of input to a set of output. There is a unique mapping from x1 to y1, and that mapping is characterized by a system parameters that's are h1, h2, h3, hk. Now in most of the situation in engineering problem, we have some form of trade-off in often, I mean most of the engineering problem. If you see the input output relation, some parameters of the input may increase some criterion in the output, some parameters are responsible for decreasing, so we may have to explore some form of optimization. And understanding or knowledge of age plays an important role. What I'm going to see here is that if you have complete knowledge of your input output mapping in terms of the complete knowledge of h1, h2, hk, you need not have to go in machine learning. In such cases, the classical approaches are good enough. That means the conventional optimization approaches are good enough for giving you the best solution or optimal solution. But if the knowledge is not known, so we need to feed huge amount of data to understand about age, and then for some unknown data, using that knowledge of age, we will get the solution of y, or we will get the output y. So one must be careful about while using machine learning algorithm. You must have to first see in your problem whether the input-output mapping, the precise knowledge of input-output mapping, the system characteristics are known to you or not. If it is completely known, there is no need of solving this problem in terms of machine learning approaches. The moment, which I am going to say, the moment your knowledge about age or the system characteristics are completely known, you need not have to explore machine learning. Machine learning is not needed. Now, just to say what I say machine learning or something in a few minutes back. So in a, I mean, in that perspective, before I go in block schematic, as I say that intelligence requires knowledge, and knowledge to be achieved through learning. Remember, intelligence through knowledge, and knowledge gains through learning. So in case of machine learning also, there should be learning, and there are different approaches of learning. And interesting things you will see, the way human learns in different stages of life, possibly that is understood and in equivalent form mapped in machine learning also, or different types of learning. Say in our childhood, I make an analogy like this way, which I will talk in next part of my talk. If you see the early part of our learning, as I told you, that our parents, our teachers, our senior family members and others becomes our supervisor. They guide us, they help us to learn. So that's a kind of supervised learning. Now in machine learning, if you have a kind of ground truth, if you use the level data or ground truth, the underlying pattern or hidden pattern or the model of the data, use that and learn from there, and then predict for unknown data. So that's basically your supervised learning. When we become grown up, we become youth, particularly the undergraduate and postgraduate students. Many of you do not want that you would be under the monitoring of your parents or your senior. They will make and watch what you are doing and all this. So you at this stage sometimes like to learn from your own. So you like to explore data, you like to see the pattern inside the data without taking help of any supervisor or anybody guidance, and then you discover the patterns in an unlabeled data. So that's your unsupervised. So you are basically going for defining a class, you are going for solving a clustering problem. So maybe our youth is something like exploring without data, understanding, revealing, or learning without the help of any supervisor. Now in the later part, when we go in a professional life, when we go in family life, you will have a completely unknown environment. I use this term. Yes, if you have your friend, known friend becomes your partner, but eventually in most of the situation, it's seen as an unknown environment. And we often sometimes say for our close people, known people, oh, you are people like that. I could not imagine like this way. What does it like to mean? In your professional life, you are having in an working ambience or environment. In that environment, it seems to be an unknown environment to you. And in that environment, you are exploring, you are adopting some policy, you have certain target, you have certain goal. And if you take certain action to achieve certain goals, you might have some reward, you might have some penalty. Same thing like in your family life, when you go, you are having parents, you are having new people, new members, and you need to adopt certain policy, making with an objective of some goal, keeping keeping harmony and peace and happiness. And you have to adopt some policy, and you might have every step some form of punishment or some form of reward. So I will be talking about this. Well, I may cite another example of this last part, which I'm going to say that reinforcement learning. So it's basically supervised learning early stage. There are unsupervised learning at the youth stage, and the professional or the personal life achieve there are reinforcement learning. Your every action enrich you, and in taking different policy in order to maximize reward, reaching the target or goal. Well, next slide, I like to say in brief what the machine learning, which I already say, ability to learn without exploring the program. So there is level data. The machine learning algorithms like to say learn model and then for non-label data you apply and make the prediction. So as I already say, it's learn from and make prediction on data. So as the way human gain experience and improves the performance, it's something like same way the exploring data more and more, learn and incorporate this for more and more accurate prediction in data. Now next comes in the deep learning methods. What is deep learning? It is again a subfield of machine learning. There are lots of algorithms or tools techniques in machine learning, support vector machine, then your uh, uh, forest. There are Gaussian mixture model and many such. I'm not going to all this. I'm talking about all this. So my whole objective here is to focus on deep learning approaches and all this. The deep learning you like to mean is a subfield of machine learning, which is having an exceptional learning abilities to multiple levels. So learning not in a single level, learning from the multiple levels. The way we learn also, sometimes when we learn new things, we go first times, we understand something, then second time we go, and then like that. Here it is not like exactly similar way, but different layers are there. Different layers are responsible for learning the different attributes of the data. So learning in the multiple layers. And more important things that deep learning has, it does not require the handcrafted features like other conventional machine learning approaches. So for example, you are solving any pattern recognition or image processing problem, and you are using support vector machine as a kind of classifier or any kind of regression model, or you are using random forest or any other kind of machine learning approaches. But what we there do, we extract some features, and that extraction of features involvement of the human being. But one of the major objective our in this automated system design, automation automated system, that is machine will look or behave like a human being without or less involvement of the human being. So our whole objective is the making or designing automated systems. So if we incorporate these features that's in conventional machine learning like support vector machines or other cases, we extract features, and that features are fed and used for the classification problem. But these features may be over specified. These features extraction may be again subjective. The feature extraction will time consuming. On the other hand, when we go for deep learning, we need not have to make use of these handcrafted features. The features so-called will be extracted from the data itself, and it does not involve this over specified or under specified the problem, or it can easily adapt to learn. So as an example, what I'm going to say, and its utility in the form of handcrafted features. For example, in in image analysis, often we use the edge as a features. Now for edge extraction, we will use different edge operator. We know that digital image, the edge is characterized by digital derivative operator, and we know that digital derivative operator can be defined in many ways. First order derivative, which are responsible for thick edge, or second order derivative or Laplacian, which are responsible for thin edge. Because if you handle say for example your chest skeleton, and you will see there are lots of ribs and bones, and they would be thick and thin. So when you use for enhancement or analysis of that images, you must have to choose some form of edge extraction, and this is one which is responsible. That's called Sobel operator. Or there are other other operator one can use, like say Prewitt operator or Robert cross gradient operator. So these are operators, and this is second order derivative like Laplacian, means this is responsible for thin edge. Now this kind of things we use in the conventional machine learning algorithms. But what's the problem? The problem is these parameters, this filter coefficient, what in a language called filter coefficient, these coefficients are fixed. And how do we expect that when you use this fixed parameter for a large set of images with diverse characteristics, they will perform with equal accuracy? Definitely not. So that's the problem. Whereas in case of deep learning algorithms, these filter coefficients responsible for feature extraction can be developed from the large set of data. So that's why it is expected much higher accuracy than that of these conventional approaches. So deep learning, as I already say, working like human brain and processing data. That's the way human makes decision. And as I say, it works on the unstructured or structured data and unlabeled data, and it can be applicable to extract features for uh, classification of the images, understanding or learning from the multiple layers, and as I say, that one level is responsible for line or edges, and the other level is responsible for the complex structures like shape and all this. And a small portion of the images to be used. So benefits of the deep learnings are there. As I already say, that unlike other machine learning approaches, the machine learning approaches make use of the handcrafted features. So in deep learning, there is no handcrafted features, which seems to be over specified, time consuming, and are not easy to adapt. On the other hand, learnable parameters are easy to adapt and easy to train, and they are very flexible for mapping the real world problems in finding the solution. So learn features are very easy to adapt and faster to learn. As I say, flexible, universal, and learnable framework. And both unsupervised and supervised we can learn. And more important thing, the learning can be done from end to end in multiple layers. The learning to be done in one, not in like that isolated level to be learned or parameters to be defined. This is learning from the end to end, effective from end to end learning. And but the challenge is that say it needs to utilize huge amount of data. In other sense, it needs huge of data for its performance or for its training purposes. Now, let us look briefly what exactly like to means the neural network. It's basically a computational unit like some nodes, which we call the computing units. That's nodes, the input nodes that provides the input data, and that's the hidden layer or sort of the nodes that's are responsible by some weights and biases. So this is basically a nonlinear functions or an activation functions. We'll come across this activation. They actually say which connection seems to be important and makes a kind of mapping. So activation functions, there are in existing literature, you will find that there are sigmoid function, tan hyperbolic function, rectified linear unit, the ReLU, leaky ReLU, all these are there. So the parameters that we need to learn is basically, these are the learnable parameters, these weights and these are the biases, these we need to learn. Now, when you go for this extension in deep learning or deep neural networks, there would be multiple layer of learning, layers, and the question comes, how do we train, how do we find the weight? For example, in this case, it is no problem because the output layer and this represent. So if it is a representation layer, this representation layer and output layer can be easily, weight can be easily calculated, trained. But if there are multiple layers, which in case of deep neural networks, and how we can do, that's basically a problem. Now question what I need to answer, that this is not new, that were there in 80s also, and that had been explored a lot. Now recent times this appear in the form of deep neural network. The reason is breakthrough is because of the three things. One is there are huge amount of data, as for example, as I say, the large set of data is one requirement, and that was not earlier available. Now here are huge set of data available. Second things are processor having improved, and lots of algorithms for optimizations are developed. So all these three things makes possible the emergence of these new neural networks. And these activation functions and these parameters, these learning parameters are there, which is need to do. As the question comes, how do we get the training of individual layers? That's the challenging problem. And in deep learning networks, the weights are calculated. I think you might be knowing all this, that's the batch of sample data to be used, and we calculate the difference between the predicted and the target value, and our whole objective to make the predicted value as close to the target value. So we will calculate some error function, and that error to be minimized, and there would be some form of gradient approaches for reaching this optimal solution. So the errors are back propagated, and that's why the training, and of course there are issues that training sometimes gets saturated, and the rate of learning, all these are issues. And to overcome this problem, the other areas like say fuzzy logic and others are used in the artificial neural network to address this kind of saturation or learning problems. I don't like to pursue on this. As I already said, the activation function, these characteristics are basically to decide which nodes are important or which activated functions are responsible in the context of the current application, relevant and all this. So this is the weighted sum of these inputs, and there is a kind of mathematical operations, summing operations, and these activation functions map this into corresponding levels or corresponding class. So this activation function, as I say, there are in the existing literature, there are sigmoid function, tan sigmoid function, ReLU-like, which I am going to say. But before that, the how the weights to be calculated, that I like to answer, and particularly in the context of deep learning or deep neural networks. So that's we need to answer. Before, let me say first about the the activation function. And here, interestingly, you will see, even if you are computer science students, but if you see these functions looks very known. If you recall back that Fermi-Dirac distribution functions, when you talk about p-n junction, when you talk about the electron from conduction band to valence band, and in between there are Fermi levels. So the energy. So this is basically in electronics. Why I'm telling this? You see this function again, some way borrowed from the concept of electronics in one sense. I would say like that way, because in Fermi-Dirac function, it's the probability that's having energy x. And here you can see this mapping function, exactly similar form. In Fermi-Dirac, it was f of e 1 by 1 plus e to the power e minus ef divided by kt. The k is Boltzmann's constant, T is absolute temperature, ef is the Fermi level, and that concept is make use here in the form of this activation function. And this activation function basically maps the value in 0 to 1. But the problem is here that when you are here, there is not firing at all, and this is firing saturated, fully firing. So the disadvantage is computation expensive, convergence is an issue, and more important things, the saturation. When it comes here and here, there is no learning. It's saturated, so no signal flow comes over here. So this is for sigmoid function. Now, a scale version of this is the tan sigmoid function, just a slight change. Instead of the center at 0.5, it should be centered at 0. And this is basically your tan hyperbolic function, a slight change or a scale function of the hyperbolic function. It is also suffer from the similar the vanishing gradient problem, the saturation problem, because at this point there is no gradient, so learning not possible here also. So output is only thing is this is output is 0 centers. Now you see the term ReLU, rectified linear, and comes your basic electronics courses, that AC to DC conversions, and this negative data, the gradient problems we overcome using this kind of model. These are certain advantages, and nowadays in majority of the deep learning networks, this kind of activation functions are used because it has certain advantages. First thing is overcome the vanishing gradient problems, computationally less expensive than that of the sigmoid or tan sigmoid functions. Convergence are also very easy. So what it makes like that any value below 0 saturate to 0, and then as there are linear operation slope, so it doesn't make use of the problem of this vanishing gradient problem. But again, you see there is a difficulties. The difficulties is the negative values all are saturated to 0. So if your data by any means during the process of normalization, often you need to do normalization. Or when you will be working with transform data, the original data, you are in working in a projected space. For example, Fourier transform, if you make use for data, there are complex, and these are basically the negative data are there. So this negative data, if you are having, and this kind of activation function makes a problem. So Riki Lelu are there to add this negative data and all this. I'm not going to this part. Now, coming to this deep learning, deep learning methods, as I say, there are multiple learning. So this is an input, the cat or dogs, if the question to answer, and this is basically responsible for finding this line or edges, and the more complex concept or the shapes and all these are learn in the next stage, and we make it. So that's basically the challenge that I say, that how to train the network in deep learning, because there are multiple layers, and which neuron to be connected, that's basically overfitting is the issue in deep learning network. networks. So question is how to train the network, means how to calculate these learnable parameters, weights and the biases. So one approach is basically that's okay, let us to say that this is input. So when it is a simple network, X input, and that's the, I'm sorry, X input, and that's the target J, T, and this is the representation. So as I say, for this kind of approaches, there are no problem to get under, training of W1 and W2, because as I say, you can go for greedy based algorithms. As a computer you can understand that greedy based algorithm can be used, means you can make a target and you train this. That's very easy, because another sense that representation layer and this target layer, this is quite easy for train. But what about the other representation? That's very, it's essentially a kind of cumbersome problems, large problem, overfitting problem. So as I say, the estimating weights between the last and the representation layer, last representation and the output layer is very easy. But how to train the other? So it's a large problem, cumbersome optimization and overfitting problem. One can look for the greedy based approaches. Greedy based approaches means that the one representation layer or the output of one layer can be make use the input of the next layer. So you train this, and then this one you would straightway use as the input for the next layer. So greedy like layer wise learning. So representation layer to be or previous may be used as the input to the next layer. There are different approaches are used. For example, restricted Boltzmann, autoencoder, and convolution neural network. I skip the restricted Boltzmann, which is having the probabilistic form of this representation. I just give a slides on autoencoder. Even I just skip because of the shortage of time and others, because I like to say some application domain. So stack autoencoder. So autoencoder is something like making an identity like operation, means the data to be mapped as an output which is identical. So basically you are having this encoder and this is having the decoder. So learns mapping from data itself. Our whole objective to make the error, this reconstruction error to be minimized. So solve this optimization problem and find this weight. So this is basically the square norms. The square norms like to say that the original data encoding and decoding, so autoencoder, that's the name autoencoders. Or in convolution neural network, we make use, so next is, so this is basically autoencoders. And as for example, there is a problem, I say that overfitting problem. In order to overcome this overfitting problem, you have to follow the dropout. I mean, some of the connection to be dropped or based on with certain probability and all this. This is all very known, and I'm not going to talk about these issues. There are different types of objective function. That's the loss function. I will talk about something related to this one as the cross entropy functions, absolute error, mean square error. These different types of objective functions are used in solving. Again, I like to skip all this. One of these I will use this cross entropy in the context of generative adversarial network, and I will discuss about this in the context of there. Now, next one is coming convolution neural network. That's a very important term, but many of us do not even like to explore what does this convolution term like to mean. And this convolution term itself guide us where these tools to be used, in which application fields we can make use, because often we make use of these tools and techniques in our research problem without bothering whether the CNN is really applicable or not. So a convolution network like structure comprises of certain layers of convolution layer. Convolution means you are having a kind of data and you are having a filter. Some filter you can say, if you have some antipathy with the term filter as a filter to be used by the signal processing people, you can think of like a operator, as I saw the Sobel operator, or something like as I saw that Laplacian operator responsible for ejection. So convolution, involvement of data manipulation or operations where you need to develop a filters coefficients, and this filter coefficient when applied on data, how it's applied. Now there is a sliding window, like so that's filter put over data, there is product and sum, then you slide over past the filter and new set of data, take product sum, like that. So that's basically the convolution, and it's a linear system theory, the important convolution operation. This convolution operation, if you relate with Fourier transform, you will see, or Laplace transform, you will see the convolution in time or in image, the pace equivalent to multiplication in frequency. And as you are computer science people, you will see that multiplication is point to point multiplication. So when you do your Fourier transformation of an image and you do the multiplication operation in its frequency domain, it is computationally little cheaper when you do the partial domain filtering, which is basically the convolution operation. So it is so your CNN architecture comprises of convolution layers, pooling layer, which is something like downsampling of the data in order to reduction of this data. There are different types of pooling: max pooling, average pooling. It is at certain merits and demerits for noise cleaning, because many times you need to go for data pre-processing for cleaning noise from the data, and you may have to do some form of this kind of averaging operation or something. So average pooling or max pooling sort of things. Then I already see the ReLU-like rectified linear network, fully connected layer, and that softmax. This is basically the different layers. Now this is basically the kernel. Our whole objective, the deep learning methods, the weights of this to be learned from the data. So that's the beauty of the convolution neural. Now an important point I like to answer, that you must have to know where the convolution neural network to be used. The name convolution, as I say, it is an important operation in linear system theory. So the convolution and linear system, linear pace invariant, linear time invariant. So you will use convolution neural network if your problem partially invariant or time invariant. By partially invariant, okay, let me first talk about what is convolution operation. Let me first make it convolution operation. So let's say this is an image, binary image, and this is your filter. This filter coefficient is the design issue. When you use the normal image processing or standard machine learning algorithms, these filter coefficients are well defined. But in machine learning or in deep learning, this would not be fixed. This will learn from the data itself. So these are different filters. We make use of this filter. You can see this is basically what it looks like. This filter, if you take that, it is basically having positive and negative. So it does some form of averaging as well as edge enhancement. So it not does the edge enhancement, it also preserves some background. So this kind of filter, if you understand this nature of this filter, this positive coefficient, when you take the averaging, so these are basically suppress the noise, suppress the signal features also. But these minus coefficients are responsible for enhancement. Now these are very well defined. If you go this kind of stride and the product, so you take the product, this is the filter one, so take the product, the value is coming as 3. So next one is like that, so represents this for each filter. So this is basically the convolution operation. Your window or the filter is sliding over past and you are taking these values. Now these are basically the features maps. You are different filters you are using over that, and there are a large set of filters in your machine, deep learning algorithms to be used, and these are the features map we are getting, and then we are going for some form of averaging, so we reduce the complexity. So as for example, as I say, the max pooling means you are taking the maximum value as a representative of this one, so like this way, so there's the reduction in the data size. Now I answered to the question that I was going to answer, basically what to use. You see, you are going for making a classification problem, whether this is cat or dog. So what you are doing, you are having some numerical data, you are doing convolution, you are doing max pooling, then convolution, max pooling, like that. Flatten means that your what I would say, one-dimensional data to be converted into two-dimensional form, and then you are having fully connected, and then you are having a classifier which make use of some activation function of sigmoid like 0 and 1 values and makes it simple. But the question that I like to answer here is that the CNN to be used partially invariant systems. By partially invariant, like to means what? Now, if a value x1 if you apply some operator and it produces y1, the same value x1, if it occurs in other place, and if you apply the same operator, it must produces y1, then this operator is called space invariant. Means irrespective of the position of the data, a particular operator on a particular data will produce the particular output, irrespective of its position. So that is basically the spatial invariant. If you work with speech or music-like signal, then it can be thought of like time invariance. So if your data is following kind of spatial, or if your system, your problem domain retain the spatial invariance property or time invariance property, you can make use of the convolution operation or convolution neural network. That's theoretically. Pragmatically, if there are local correlation, that example I say, image, video, speech, music, samples are highly correlated, means one value with its neighbor value, there are high correlation, and we exploit that in predicting future values. There are many data compression algorithm like, or data coding algorithm like pulse code, DPCM, and all these, and in many data operations, the some form of prediction, we exploit this redundancy and correlation, particularly in the data compression. That's so we will at least look, if there is no spatial invariance, we will at least look whether there is local correlation or locally correlated systems. But we never bother about of this. We use without understanding whether it to be applied or not. The moment we see any matrix, we are tempted to make use of the CNN. So that's I like to say. Now, typical one example I am taking is now next part I will be talking about some form of application. So this is basically a problem of skin cancer detection problem, and this is a research group. Actually, these people are in University of Alberta, Canada. They are working because you know this in Canada and other places, the because of this temperature and hot, the skin cancer is basically a issue or a problem, and early stage diagnosis is very, very important for recovery and all this. It is basically like to say histopathological images, and that histopathological images are obtained from the hematoxylin and eosin strain histopathological images. And what is generally done here, there are two stages. I'm not going to make use of details of this. What I'm going to say here is that how this convolution neural network framework is used to address this problem, and how the limitation of this problem you can make use other. My whole objective here is to choose a tools and techniques of deep learning or machine learning to address this problem. The problem is this is in histopathological images, and here is this, I mean, epidermal layer, the different layers of the skin, and you need to find out the nucleus, and that nucleus which are, I mean, malignants, having this malignancy, we need to identify that. So melanoma region marks detection is the second. The first one is segmentation of the nucleus and nuclei, and that nuclei to be used for detecting melanoma region marks, because if you can detect the melanoma region marks, it can make use, it can help us for radiotherapy and others, I mean the chemotherapy and all this for the subsequent medical treatment. So two steps are CNN based nucleus segmentation and melanoma region. In fact, in this melanoma region detection, we make use of different morphological operations, erosion, dilation, and others. So this is basically, but there is an assumption. This algorithm works subject to that nucleus detection should have accurate. If this is a cascaded operation, you try to understand. So if the performance of this stage is not good enough, the subsequent accuracy will fall. So this framework will work. Why do we use the CNN? Because it's an image like, and there are correlation. We cannot expect that a melanoma region to be represented by a single isolated point. It will be over a region. So they are the characteristics, they should preserve some form of correlation and invariancy, and that to be extracted by means of this convolution neural network. So this convolution neural network is used for identifying this nucleus region, and that nucleus region, once identified by means of morphological operations, the regions, I mean melanoma regions, can be detected. So once the nucleus are detected, melanoma nucleus detected, and then we can identify these melanoma lesions. But again I'm telling, because I will take this example in the subsequent next discussion of other learning approaches. This performance depends on how accurate you are. As per our current, this is the paper, we find this 94% accuracy, whereas the melanoma detection accuracy is 85%. So there are improvement, there needs improvement in this stage as well as it, because 85% is not also a good, but that's one way one can address, because this early diagnosis is very important for the medical treatments. Now, second problem that I like to say, the convolution neural network, how it can be make use in different architectural framework. As I say, in medical domain, there are scarcity of data. Here also, I like to say the data are very less, 300 something, 22 or like data were used. So this was for training, testing, and validation. So this is basically a small set of data. So data scarcity is is an important point. And how to generate the synthetic data, or how to go for data augmentation, that's an issue. And in medical domain, that's very important issue. Now take an example of MRI field. I didn't take this all example. So in MRI, you know that it's a time consuming process. It takes longer time for image acquisition, around 40 minutes or hour times it takes. Now, another requirement in MRI is you need to make the patient static during capturing this. And for age-old problem or for pediatric patients, taking a longer duration of time, keeping them static and capturing this data is really very difficult. So MRI somehow performs longer duration. And in such cases, you may have to work with sub-sampling, means your sampling or your data acquisition to be very faster. You may not have the full resolution images. So how to get good resolution or high resolution images from the low resolution images? So this is basically a challenging problem. So improvement in the reconstruction through training, but in an unsupervised manner. So this an autoencoder model of high-low high operation, means we are suppose having an input high data, high resolution data, but somehow our decoding, acquisition process gives low resolution image. How this to be used to have a kind of this high resolution images? And we like to say there is a generator model. The generator model will learn the patterns of the data, and it will generate some data. These data are not actually real data, but our whole objective is the data to be closer to the real data, and that how closer or not, this to be distinguished by a discriminator network which works on the concept of supervised learning. So we'll be talking about a new architecture. As I already say, the problems, the perspective to talk about my new architecture, that's scarcity in data. Medical data needs fulfillment of ethical issues, and we need data augmentations, create data from the existing ones. And this may be an issue that low resolution image for high resolution. MRI data, suppose you are having a low resolution images. From low resolution image, how you can go for high resolution images? Using a generative adversarial network model. So next I will be talking about GAN. Basically, GAN is a network or deep learning models which works on the concept of an unsupervised learning approaches. By name generative means it is an unsupervised learning approaches, but there is a clever tricks as if there are supervisor, that discriminator. The discriminator help to generate data. So it's an unsupervised learning that involves discovering and learning through regularities or patterns in a clever approach, so that the generated data as if comes from the plausible data. So what I'm going to say is that suppose you are having a kind of latent parameter. The term latent parameter is used like the term latent, which we cannot notice, like heat latent. So some latent means which is very important but not easily observable. So that latent pattern, using this latent pattern, we like to generate data as if the data comes from the distribution itself. So there are two models. One is generative model that generates new samples, and generative model works on the concept of your, what I would say, that it works on the concept of unsupervised manner. On the other hand, discriminator model, which discriminate whether the generated data belongs to real data or it's a fake data, and it works on the supervised model. So, and we will see later that there is a tug of war during the process of training of generative network and discriminator network. Let me take an example that this is a generator, it's a deep learning, deep neural networks. Discriminator is also a deep learning network. So latent random variable, it may be a random noise like also. So by latent random variable, what say, for example, you are working with sort of a compact representation of the data and you generate some sample, but here is the real world image or real data, and therefore you take the samples. Now the discriminator is like a distinguisher. It will just distinguish whether this generated data is original data or fake data, right? So as I show here, random variables, latent random variables, it can be of random noise. It can be of random noise in the sense that it starts with some random noise and it generates some samples. Obviously, these samples are not like real data. These are fed to a discriminator. Discriminator, I mean, help in learning of the generator process so that it updates and it's again go on updates. So there is a tug of war between generator and discriminator. The generator like to generate new data which seems to be real data to make the discriminator fool. On the other hand, discriminator will try its best to distinguish the generated data as the fake data, not the real data. So there would be some form of tug of war going on, and that convergence becomes an issue. I'll come to this again in the next slides. In medical problems, say for example, I already told super resolution imaging system like X-ray tomography or ultrasound imaging, radar imaging or MR imaging. So to reduce the computational cost to maintain real-time speed while reconstructing the image in desired areas. See, this I'm talking on the perspective of simple computation. Suppose you are in the patient end, your doctor is also there, you are capturing image, but the slow process of the MRI you are solving by taking undersampled data or low resolution image, and you are going for generating high resolution images. Now, think about if it is a communication problem or remote health monitoring problem, means your patients are at one end and your doctor in the other end. So if you are having a low resolution image, you are having a less amount of data, and if you transmit through wireless channel to a doctor or the reconstruction center, pathology center, which will reconstruct and analyze, it will reduce the burden of the bandwidth. It reduces the burden of energy for the transmission nodes. And imagine in the context of IoT healthcare support, because the nodes are battery driven. So these nodes are having less memory. These nodes are having limited computation. These nodes are limited battery. So you must be looking for processing or developing techniques which would be energy efficient, bandwidth efficient for the delayed tolerance system design. So a low resolution image at the capture or the patient end needs transmission over a wireless channel in the far end and need reconstruction. So low resolution image at the far end reconstruction question, we can take help of this generative adversarial network. So a CNN is a measurement. In our, this is our own work. What we are going to say, we are having a generative adversarial network model, and this generator model is basically a kind of auto encoder. This upper one is the generator model, and this is basically your auto encoder model. So we were having an image, you are having a subsample, I call it a compressive sampling measurements, and that compressive sampling measurements and noise, we are having the convolution, downsampling, and then deconvolution and upsampling. It generates reconstructed image. But this is the original image, and this is fed to a discriminator. So discriminator distinguishes whether this generated was your original image or not. So what image to be sensed? Actually, this is not the image we sense. We consider it as a raw data or fake like, or say take the latent random variables, the distribution this follows, and from there we are generating a high resolution images. and a discriminator help us in doing so. So measurement vectors, that's the latent vectors in the compressive measurement is said, and this is your generator model. This generative model we make use an auto encoder. That's an important issue while doing for GAN network, because training of the GAN is, when I'll be talking about, you need to first define your problem, then you collect data, then you define your architecture. For example, here the GAN model, we use the auto encoder as an architecture, and that's, as I say, the model that we make use for training purposes and all this. Now, as I say that the training is very important for the case of your discriminator. Discriminator, what it will do, it will just distinguish something like whether it is a real or fake one. It's something like so this is a kind of things, and discriminator will distinguish that one. It's a kind of game. It's a kind of game between generator and discriminator. Something like the game, as I say, let's say the fake currency. Some fraudulent user are there which generates the fake currency, and police are there. So there is a tug of war. The police responsibility is to distinguish whether the currency is fake or real. So by virtue of that, the fraudulent persons will generate, the fraud people will generate more and more accurate the currency. So something like that. And the whole things operates in the framework. I will take, let's say I will come back to this part later. So if I come over here, I will come to this part here. So this is basically, D stands for discriminator and G stands for your generator. So X is the P data means the probability distribution of the real data, and PZ is the distribution of the generator. X is the sample from this distribution, and Z is the sample from the fake data. And this is the discriminator network, and this is JSCO. So as I said, that objective function of the network, here this is the cross entropy. So DX, as I say, the discriminator network, and GZ is the generator network. The whole approach of objective of DX is to make the value is 1 and GZ as 0. So that's the role from the discriminator. So discriminator will maximize the discrimination, whereas generated role is to make it 0, and that means it will make as close data, generated data, to be to the real data. So this is basically a max min like a problem, and this is the parameters one needs to update. This is alpha and beta in existing literature are used. So these parameters are the issues of this. Now back to our discussion. So these sort of things, as I write here, alpha and beta. So whole objective is to go for updating and alpha and beta, and they works on once the discriminator network is trained, generator network is freezed, and generator network is trained, discriminator network is freezed. So this is basically a objective function, and this objective function is cross entropy, and others are also used like this. The important I like to say, the training of the GAN. This is very important things, because there are two networks. One is generator network, which works on the unsupervised manner, and discriminator network, which learns on the generator model. Now, to understand how the training is done in this GAN model, as I told, depending on your problem. So you first understand your problem, define your problem, collect your data, then define your architecture, network architecture, then you train your discriminator using the real data. So take the samples from the real data and train your discriminator, so that your discriminator can identify the real data. Now you generate the fake data. Now using that fake data, you train your discriminator, so that your discriminator can distinguish it as a fake data. So once you train your discriminator using the real data, this is positive sample. When you train your discriminator using the generated data, it's the negative samples. Now once you train your discriminator using the generator data, whatever output you are getting, use that output data to train your generator network. So that's the total process of training a GAN. So as I already define the problem and collect the data, choose the architecture of GAN. So for example, in our case, we consider autoencoder as a kind of generator model and convolution network as a discriminator. Then train the discriminator with real data, generate the fake input data. So this is the positive sample, and this is generate fake input for generators. This is used for the training of the discriminator. So this is the negative sample. And once this is done, whatever output we are getting from the discriminator, that is used for generating the, training the generator network. So there is always a game between this. Both one will try to defeat other. So this is a game theory, and really this convergence is an issue. We cannot expect a convergence. And if you really go for Nash equilibrium, we will have that there is no convergence in case of, it's a really issue for GAN-like architectures. And that is the problem which will come across later, the stability problem in case of GAN. It is the limitation of the GAN. Of course, to overcome this limitation of GAN, there are different other versions. I will talk to this in later case. But what I'm going to say, the convergence of this. Now, you can see this expression, what this log, beta, and this, what this log implies. You see that I talk about X, Z, these are coming from the samples of a distribution. And this distribution, the uncertainty is the essence of information. Whether your data contain information or not, that to be characterized by whether this data is deterministic or probabilistic. If your data is probabilistic, if there is some uncertainty, then it carries information. Like say example which I prefer to give, if I make some statement, sun rises in the east, you may say, well, what does it contain? It doesn't have any information because it's just your event or certain event. If I say it may rain today, you may not even be surprised because this time rainfall is really occurring, so it doesn't contain that much. But if I say there may be an earthquake tonight, this is rare event, the probability of occurrence is less, so information content is high. Now, the term that I use, the cause entropy, because this is the probability. So information is characterized by logarithm of the probability of the event. So if your event is X, probability of X is the occurrence of that event. Information contained in that event is characterized by log Px. And when we take the expectation, I hope you know the expectation meaning. So that's the average information, and that's the entropy. And you can see this mathematical form, it implies the cross entropy because it is the involvement of Z and X, the generator, discriminator, and generated data. So that's the cross entropy model. And it's basically a min-max problem, and we look for this. So this entropy, like to say, when there is a game between generator and discriminator, and all efforts from the generator aims to generate data to make the discriminator full, the success will come when the discriminator will be really puzzled whether the generated data is real or fake. And puzzle implies the entropy in the binary case, the maximum. When you throw a die, if you toss a coin, if your coin is unbiased, if you are having 50-50, whether head or tail, so uncertainty is maximum. I think in binary random variable case, in information theory, you know that the umbrella-like structure, probability 0 and probability 1. So when the probability is half, if you go for zero-sum game, so half, this indicates that the generator is working. So there is a game theory perspective, and there is no convergence at the end. However, generates applicates so that DN cannot take the difference and predicts unsure 50% for fake and real. So that's the issue of the convergence. As I already told, there are a couple of issues in GAN architecture. For example, there are stability problem between the discriminator and generator network. There is the perspective problem, whether it is a 3D or 2D scene or something like that. So these issues needs addressing, and to address that, there are different variation of this GAN are coming. So some of the GAN is vanilla GAN, deep convolution or DC GAN, conditional GAN, super resolution GAN, cyclic GAN. So I just like, before I going to screen, I don't like to say much. One of the typical application I like to say here, these are other works. So for example, vanilla GAN there are generator and discriminator networks are comprising of multi-layer perceptron, and loss functions are used gradient descent algorithms. On the other hand, much of this problem of these GAN architectures now being overcome by deep convolution or DC GAN. This DC GAN implies that the generator and discriminator models, instead of multi-layer perceptron in vanilla, it's like your convolution nets, and we do not use the pooling, max pooling, rather stripes pooling is are used here. Conditional GAN means, let's say X is your samples for generator and Z for samples, let's say for discriminator. You need to provide some other extra input to the discriminator apart from the real data in line of my language of GAN. So your discriminator will fed apart from the real data some other level data to be done. So some conditional, some extra input to be provided in the conditional GAN networks. Super resolution, I already discussed about this in the context of my autoencoder based high resolution to low resolution image reconstruction. So super resolution or ISAR GAN, and there are cyclic GAN from one object to another object. Say for example, you like to generate zebra, you generate first horse, and from there you again go back to the zebra. So it's kind of cyclic GAN. So I already talked about whatever I need to say here is that vanilla GAN, the generator discriminator use multi-layer perceptron, and gradient descent, stochastic gradient descent algorithms are used for this. I already discussed. Now, in the context of your DC GAN, this is basically, as I say, instead of multi-layer perceptron, it is the convolution nets, and without max pooling, we are basically, these are using convolutional strike. Now, this has been used in the context of liver lesions, and they make use this one as a data augmentation. I mean, they are scarcity of data, so make use the generator, this model for generating data, and they show the improvement in the performance by sensitivity and specificity is the measure of image classification, medical image classification, segmentation problem, and this has been increased to this performance. So data augmentation and its subsequent analysis performance improved when we make use of this kind of operations. Next one is conditional GAN. As I already say that real data, I mean the discriminator apart from this, they make use of, use the extra data. Why? So why, for example, that is the level data. It's a level data. Say for example, when you like to go for image translation from one, GAN can be used from image translation, means image from day to night or image from summer to hot. So in such cases, you can distinguish when a discriminator, so it is, let's say for example, hot image, during summer. So this may be another leveling data of winter, and that can be make use for the distinctions, right? Then, as I already say, a typical example of cyclic GAN. So here you can see this is a zebra. You like to generate something like that. I don't know whether it's zebra or not. Maybe this is. But when you generate using this kind of vector, this generates a kind of fake image on this. Now again, this from here, we are coming back to, we are generating this one. So this is basically a cyclic GAN, which can be used for generation object to object translation or image to image translation. That I say already, image to image translation means night image with respect to the day image, or summer image with respect to the winter image, like that. The translation of this is done. Summer to winter and winter to summer image, this translation is there. Then the next and last one which I'm going to say is the reinforcement learning. And here I like to say, you see this picture, you can see there is a puppy or a dog, and you can see there is a people which is having a kind of stick or like that. This is an environment. So this is an agent. Agent is who? That agent is an environment. Agent will take some action, and based on its action, in order to meet its certain objectives, it will be either rewarded or punishment. You see, the invitation may be in terms of some food, or invitation may be in terms of beating by the sticks. So there are rewards and there are punishments. So reinforcement learning is an machine learning, like unlike your supervised learning, it's basically an unsupervised learning, where a software agents take certain action in the environment so as to maximize some notion of cumulative reward, right? So it has certain objectives, it has certain goals, and in order to meeting certain target or goals, it always adopts some policy to have maximum rewards. Take an example of our childhood. So when we learn walking, often the children when trained for learning, walking, the parents stand in other side of the room, maybe in the bedroom, and having in hand some chocolates or candy. So the children will attempt to move towards parents in order to get that candy, or but while going so it fell down, it stuck with wall, so that's punishment. Or after one or two occasions when it fell down, the agent, the child, will try to take help of the wall to move from one place to another. So some policy it adopt so that the reward to be maximized. So reinforcement, by name the reinforcement, means revealing this pattern and understanding from there. So an agent is put to an unknown environment, and in that environment agent explore, it takes some actions, and every action gives some return, and with respect to that rewards or certain punishments there. So reinforcement to establish or increase the pattern behavior. As I already tell, that an agent is put to an unknown environment, and it gains experience by means of trial and error approaches, hit and trial and approaches, and explore and exploitation. The term exploration and exploitation I will discuss later. This is very important in the context of reinforcement learning. So it takes certain action in the environment to maximize some reward. For example, the child, a few minutes back that I example, the child is an agent, right? It learns to walk, the action, it makes gets some candy reward or gets hurt from the obstacle setback from the environment, that's the living room. So you can see in supervised learning we have the level data as the teacher, but in RL there is no level data. It's input in an unknown environment and learns by hit and trial. It needs to adopt some policy to meet the targets or goal through some reward maximization. Now I need to, before I say what's, I need to go for some terminology which is very important to know in the context of RL or reinforcement learning. One is the agent. What does it like to mean? The agent is nothing but an entity which takes certain actions in an environment. What is the environment? Now all possible moves, a situation that an agent faces. Right, say for our typical example, living room is an agent. So agent is an entity that performs certain actions. Action is what? Now all possible moves by the agent. Environment is the situation that an agent faces. State, the current situation written by the environment. And reward, as I see that reward is return from the environment, some form of immediate return from the environment based on the last action. So reward is what? So some agent takes certain action, and with respect to that environment returns something, and that is basically the reward. There is long-term reward with certain discount, that's we call as value based on certain policy, and there is other thing that's called Q value, which associates some action. So some of the next definition we like to say policy. The policy is the strategy which an agent applies to determine the next action based on the current state. That means the agent in a particular state, it will take certain action, some policy it will adopt. What would be its next action? And the important term, so value, policy, and Q value, those are very important. The value is what? The expected long-term return. Why long-term? Because there will be every return from the environment based on certain action should not be having its full value. It should have certain discount. So the return or the reward with respect to current action might have implication in the long run. So return with discount, expected long-term return with discount as opposed to the short-term return. So it's defined as an expected long-term reward or return of the current states is under policy pi. Now the same thing is Q value with certain change, with little change. That little change is the Q value is similar to value, means the expected long-term return of the current state is under policy pi associated with certain action. I mean taking action A under policy. So it's basically the long-term return with respect to certain discount based on current action. I mean based on current state with taking certain action under policy. Now in most of the cases you will see the solution, I mean when we will be going for reinforcement learning, the environment, as I say already, I mean completely unknown. It's stochastic in nature, and real life successor is not deterministic. The real life target goal are non-deterministic, non-random in life in nature, and so dynamic and complex. So one model can be that is used the Markov decision model, MDP. I didn't include all this typical mathematical term and all this so that it will be. So I already talked about the policies and value functions. Take this example which I was going to say, reward like function. The term exploration and exploitation need understanding here. You see, this is a typical environment. In RL, we will have to have certain, that means agent to be trained in such a way so as to have its maximum reward. So reward maximization theory states that agent to be trained in such a way that it would be maximum reward. Now you take this is an example where it is a fox and there are chunk of piece of meats and there is tiger. Now if fox is in that, I mean one end of this room, and if it stay here, it is having this chunk only piece. But if it is come over here, it will have scope of getting larger chunk of meat. But the problem is it has a penalty of being killed by tiger. So the reward, what you can say, if the fox is happy, sorry, yes, if the fox is happy with staying over here, means it is exploiting its current information. It is happy with this one only. But if it's come over here, it is exploring, and it is exploring to have larger chunk. So if it comes over here, there is a risk of being killed by tiger. It's something like, to have a better example of reward and exploitation and exploration. Say often the student for exam, for any competitive exam, like to collect books. For a particular subjects, you like to collect book. Some people very eager to collect, go on book. Oh, this book is not good. Like that book, that book, that book. So go on collecting books without going inside the any books. If you go inside the books, that means your exploiting. And when you look for more and more like books that exploding, something like analogy like that. So there must be a trade-off. Obviously, you will be looking a good book, but at the same time, you will be go inside the book. So that's gamma is the discount, and it should be 0 to 1. That means if gamma is 1, you have to explore all possible paths and larger computational problem. If your gamma value is very small, then what would happen? You are having training is incomplete. Your learning is not complete enough. You may have less computation, but reward will not be maximized. So it's something like what I like to say in that sense other way. The larger value of gamma means more and more you will explore, you will have more and more learning about the agent will learn more and more about the environment. So that sort of things I like to say. I mean, more you explore, more you learn. Something like joto beshi pore toto beshi sekhe. So smaller the value of gamma implies the agent does not explode the seems to happy with the current reward. And larger value of gamma implies more exploring the environment. So exploitation means Fox is here, happy with that. Exploiting this using the already known to heighten the reward. Exploration, exploring and capturing more information about the environment. So some form of trade-off, some choice in gamma value. Come back to our melanoma detection problem. I say there were two assumptions. The first assumption was training and testing data set is small. Second one, as I say, there were two steps. One step was nuclear detection, then followed by melanoma region, malignant region detections. Now, if your nuclear detection is not good, then you will not be able to have higher accuracy in MRD, melanoma region accuracy. So, this data scarcity problem one can take care by using GAN network. Generative adversarial network can be used for data generation in augmentation. And one can make this problem in the framework of reinforcement. Many often you use the seed-based techniques. Those who are familiar with image segmentation, you know there are region growing techniques where you take some arbitrary seeds, then grow the seeds to have the different objects. So region growing techniques works on the seed-based approaches in image segmentation problem. Now here you can make use of reinforcement learning approaches. You start with some seed and you make use of an penalty and reward in your function such that you do have a good accuracy of nuclear detection, which will consequently lead to larger accuracy in the melanoma. So one can, the previous approach of CNN can make in the framework of GAN, and that can be make use for this improvement of data problem, scarcity of data problem, improvement of this data accuracy. I think one can understand or make this problem in the framework of your GAN or in a reinforcement learning framework. Now I will be talking about another problem, wireless multi-hop routing. As I already told, you will be, many of you will be working on IoT, and in IoT there will be several number of nodes. This node will communicate with each other, and for their communication they need some channel. Now these channels are not free. There are lots of services. So channels are really scarce and costly resources. Like your computer, the resource problem of memory and processor, here also it is a scarce resources. And we have to go for sharing mode, opportunistic mode of operations. There are different techniques in spectrum sharing, like multiple access techniques, FDM, frequency division, time division, code division, there are millimeter wave communications, there are cognitive radio concept and others. So in a multi-hop routing problem, from source to destination, message will be relayed, and there are many relays. The relay, when talk to another relay, they need some communication channel. Now when from source to destination you take help of many relays, let me go to this example. Some methods, as I like to say here, that's, let's say, for destination, and that's a secondary. I like to use, I use a term secondary. Actually secondary is the term from the cognitive radio network. I don't like to make you troublesome by using cognitive radio concept. Let us consider it is a cellular form of communication, cellular network. This is the dedicated frequency, and these people will share this frequency in an opportunistic manner. Means there are a certain range of frequencies. This frequency primarily is used by this primary user, but when they are free, these to be used by these nodes. So that's why I call them as a secondary users. Now this relay or secondary nodes, they makes a multi-hop problems. Now we need to assign some relay, some channel for each and every relay. Now the data transmission, because you are opportunistically using your channel, so channel may not be free, or whichever is now free may even immediately be taken by this primary user. So within the short time, you have to transmit your huge amount of data. Or with less power, because this is the IoT nodes forming a multi-hop network. These nodes are battery driven, so they will be looking for data transmission with less power, which we call as energy efficient data transmission. So your relay will establish a path so that the delay will be less and data transmission will be energy efficient. So that's an objective. And if the link is not available or link does not carry a certain amount of data, we call it as an outage. So that's our objective, that we'll be looking for a path setup, and path setup to be followed by means of reinforcement learning. What is that? Now, out of this many possible paths, which path to be followed? I mean, through learning, the reward is what? The energy efficient data transmission. That means if a path consume less power for data transmission and incorporate less delay, the path to be chosen. So that's the reinforcement learning based approaches. And this is the time frame, as I say, that these nodes, I mean, whether the channel is free or not, that's the sensing. And if the channel is not free, that means this is communication is going on, then nodes will harvest energy from the relay node, I mean the primary nodes. Otherwise, if it is free, it will transmit data. So this routing process is based on certain queue method or queue routing. What is queue? As I like to say, actually I need to say about this in the context of reinforcement learning, but I didn't have that much of time. MDP, basically Markov decision process, because this is say these wireless channels are complex and heavily dynamic. The moment this frequency is free, after that it is immediately after that it is engaged, or I mean occupied by this one. So it's a complex and dynamic process and you can go for probabilistic, I mean state action methods, the MDP, and there are queue learning methods. Actually queue learning in MDP process is basically your memory like systems. You are having some reward function, you have reward matrix. From the reward matrix, based on certain action, you have the queue matrix, and like that. So I am not going to that part. So this is one approaches for reinforcement or queue learning. Basically the queue learning, it's a reinforcement learning approaches that's make use. Now same concept, forget about, you are not in use of people of data communication, but some you like to work on smart city problem, and the same concept you can make use in your intelligent data transportation problem. That I'm going to see here is that, you know, the smart city is the future promise, and we are looking for that automated vehicle systems. We are looking for the electric vehicle system, because all we know the fuel are getting reduced and they emit carbon, and environmental issues are there. So we'll be looking for electric vehicles, and that electric vehicles provide energy savings, reduction in carbon and environment protection. But again, all you know that this electric vehicle system has limitation. The quenching range is limited because of the capacity. So you need to go for battery charging. So you will be looking in your path, in your road, there should be charging station. Now, before reaching the charging station, the vehicle must be ensured that the leftover battery power is good enough to reach that. Now, in the charging station, like your petrol pump, and you know that there are multiple and there are often sometimes queues. So you must have to have a scheduling, electric charging scheduling, so that the overall charging time, overall travel time will get reduced. So energy in my previous work, if one can think of the city destination, source to destination, and if you can think of these are some of them are basically the charging station. So you can look for a travel path, optimal travel path, such that you do have this charging facility, you have the energy efficient data transmission, I mean transportation and relay as well. Sorry, I mean delay as well. What does this like to means? That you do have a less queuing problem. You do have, I did in the context of transportation problem, the road condition plays an important role. Whether there are valleys, whether there are hills or not, whether there will be jerk or not, because that jerk is again responsible for the energy consumption of the electric vehicle. So what in a wireless condition you do not consider? Of course, in wireless condition also good channel, bad channel. Because if there are obstacle, your data transmission will be obstructed. Same thing in the transportation problem, the road condition. If there are hill, if there are valley, if there, so that's again a jerk, and that's responsible for energy consumption. So one can look for the same algorithm, the same methods. If anybody of you are interested to work with, I can say this paper, if you explore, and you can easily map that the spectrum information, like that which road to be free, you might have some information a priori available, that during this time this sector or this segment of the route to be do not have any traffic, so you could make use of that, and by that way one can look for energy efficient electric vehicle transmission with less delay. I can take another example. I tell that the charging station. Now, some charging station may have the high power. I mean, the charging rate is fast. Somewhere the charging is slow. If there are charging rate is fast, many of the vehicles will be there. So there will be congestion. There will be queuing problem, and there are number of piles to be there for charge. I mean, electric vehicle charging. So one can think of this intelligent transportation problem as total charging time, reduction of the total charging time. I mean, which charging station to follow, which path to follow, so that the queuing time or overall delay in the transportation would be reduced. And it would be energy saving approaches. The recent work, they make use of these approaches or like that. I will quickly go to, I skip this one. I will have another example to say, and I will just, I think I'm running shortage of time. So security in wireless communication. Many computer science people, when I say security of the I mean data security, you mostly tempted towards the cryptography techniques, or you can have media security like watermarking, visual cryptography, or if you can go for secret sharing and all this. That's true. Actually, if you go for in your application, I mean network layer, the cryptography is basically in the involvement of the application layer. You all know about the cryptography. What is you are having plain text, you are using some, so Alice and Bob, there are exchange of data, ifs are there, so Alice encrypt the data to Bob and using some key and if so that cannot decrypt. But management of key is a very, very troublesome approaches, and you do all these operations in the application layer, which are power consumption. So this is a basically operation, I say, that Alice like to communicate with Bob and ifs are listening. That's basically eavesdropping. And somewhere Alice take the message and change it. So passive, I mean active. So or it can create some form of jamming, high power signal to create jamming. So what I was going to say, in cryptography there are issues. The power consumption is large. Second thing is you need to always look for the management of the key. For example, you like to make your room more uh, I mean safety, secure. What you will do, you will use more and more number of key, so that a third party cannot come and open that, broke it. But again, it would be headache for you also. You need to carry all this key. While you return back home, you have to open, and if anyone is lost, you will have to face that problem. Now, if it is a communication problem, yes, it is a communication problem, and data to be transmitted over a wireless channel. Wireless channel is the God-gifted channel, natural. If I can create a good channel, if I can create a bad channel, I can ensure security. And there are possible in many signal processing techniques that Alice Bob like to communicate. So I will make all my best effort so that Bob can get a good signal, and I can create a bad channel. That is possible. That is possible because of the computer science, thanks to software engineering people. Because this wireless channel, nowadays this is used, that reconfigurable software, I mean channel, or reconfigurable reflecting system surfaces, reflecting surfaces. Because when your data transmitted, there are reflection. So reconfigurable reflecting surfaces are there, which can create a good or bad channel. I take the example of physical layer security. I take the problems of the cryptography key management, and cryptography techniques, power or energy consumption online. So in signal processing, there are multiple antenna can be used to create a good channel and create a bad channel. So when we say good channel and bad channel, so here data transmission rate is high, here data transmission rate is low. So there differs transmission rate, and the larger this difference, the data would be more secure. and that's basically your physical layer security. So what I'm going to say is that secrecy capacity, the term that the data transmission rate in the main channel, data transmission rate in the eavesdropping channel. And if this value is positive, that's the secrecy. And if this limit, I mean, what does this like to means? That if this difference below this is, so that's the probability of failure. Secrecy out is probability. That means if below this, I mean, if so, that's the outage. So forget about this mathematical term. What I'm going to say, I need to create a good or bad channel, and by means of machine learning, I can create a good channel and bad channel, and that is the trend people are using these days. Say it's an example, RL, reinforcement learning in intelligent reflecting surfaces. So this is a base station. This is multiple channels. I mean antenna, and this is basically your valid users. These are all users, and these are eavesdropper. They are eavesdropping. Now, what you can create? This is an IRS, intelligent reflex reconfigurable surfaces. So what is? It's are all passive. Earlier, what we do? We are having the relay. In my example of this one, I say it is a relay, but this relay make use of some power. But what is the example? What this says? It's basically the passive components. That means it is passive devices, some metals, your electromagnetic wave, and multiple reflected wave. We will set the phase in such a way, because signals are nothing but a vector. If two vectors are in phase, the resultant vector is large. If the two vectors are opposite phase, the resultant vectors are low, small. Basically, all signals are vector. And if you, in your receiver, in wireless communication, you get multiple copies of the signal, and that multiple copies are the multi vectors. If you add them in phase, your signal would be good. If you have the distraction, I mean opposite phase or out of phase, they will have bad. So that strategy to be done such that eavesdropper should have bad channel, and eavesdropper should have bad channel. This is eavesdropper, and they should have the good channel. In this recent work, what they have done, they have created the secrecy. So there are k number of valid users. So calculate the secrecy of individual. The minimum secrecy to be maximized. What they have done by means of reinforcement learning. Now there are multiple antenna at the transmitter. There are beam forming such that this would be a very directional, and that's one design parameter. So V is the beam forming matrix for the base station, and psi is basically the phase of these reflecting surfaces. Under certain constraint environment, they need to optimize or maximize that. What is that? Now for the kth user, must minimum secrecy rate to maintain. It is the kth users sum of the minimum secrecy rate of all user to be sum over, and that to be maximized. Under the constraints of another constraint means, well, if you do not transmit, if you never say anything to your friends, all data are secure. When you send, some of this may be leaked, your friend may leak. So that's why it ensure, one may ensure secrecy without any data transmission, but that should not be. So certain data transmission must be there, under that's a constraint. And the power of the base station is having constraint, and this is the constant from this. So a constant optimization they have done, and that's basically a reinforcement learning problem. I take the last example. This is one of our work. I don't like to say at this stage because this. So this is basically a IoT healthcare device to device communication. Say typical example is in hospital premises or in home. Let's say, particularly in this COVID situation, or for pneumonia or something like this diseases, we don't like to go closer to the patient. So under that situation, the patient body will be equipped with machine to machine wearable devices for collecting physiological data, like say for example blood pressure, blood sugar, or other all types of data, and that to be wirelessly transmitted, and where the doctor or the nurse chambers are there, so they will see these parameters, physiological parameters, and they may control this meditation, they may control the dose of the medicine, and like that way. So this device to device communications, I mean in a hospital premises, the existing telephone communication systems can be made use for this wearable data transmission, and these data, medical data, are very secure data. I mean needs to be secure because there are ethical issues and all this. So that's why you can have to have an environment of IRS which can ensure the security. Of course, I never say that you do not make use of the cryptography. One thing I like to say, cryptography is in application layer and your physical layer security is in the physical layer. And this is the time you make use of both. They are not competitive, they are rather complementary. And in order to have a good tightening of the security, we just make use of all this. So that's basically another approaches I like to say. So I think I'm running out of time. I will just stop with 1 or 2, 5 minutes. Can I take 5 minutes or 5 to 10 minutes more? Hello? Hello, can I take 5 more minutes?
Yes, sir. Please, sir.
Yes,
Yes,
Okay, okay. So a couple of
yes, sir.
slides only.
Yes,
Application,
yes.
as I say, prediction of next frame in video, an application of the GAN network. So you can make use, particularly in the application of surveillance. Say, for example, during storm in your campus, there may be the surveillance camera, but because of this, I mean, often in different situation, the camera is distorted. I mean, the image is uh, manipulated. So in order to create a frame from a video, we can make use of this GAN based network, and it is possible DVD, I mean, digital video discriminator networks. I mean, sorry, dual video discriminator. So that can be make use for predicting a frame from the video sequences. Text to image generation is possible by using GAN network. So you can describe about your birds. Say you like to generate a birds having the black feathers and tall tail or something like that, or something. So with that input, semantic representation, you can go for generation of images. Image to image translation, as I already say, it's winter to. So there is possibility that you can create images which really do not, human faces which may not exist. So creative art and all other cases, there are challenges in fact. So image to image translation, winter to summer, day to night, or even you can create some face images which really do not exist in the real time. Super resolution images from the low resolution, I already discussed about it. Interactive image generation, something like, so you might have a description of a paragraph and all this, you can create this. And multi-level transfer learning, there is another, because my talk title was I mean, introduction to recent trends. So I talk about these recent trends. So multi-level transfer learning, some rare diseases of say kidney and others, we do not have enough sample data. Even synthetic, I told that synthetic data or data augmentation, that's again for medical cases, it's very challenging because there would be bias when you use the GAN model for generating the medical data. It could be a bias, like, so it's not always wise to use the synthetic medical data for the diagnosis purposes and all. And that's so, but one can go for like multi-level transfer learning. Suppose a concept is something like that. No, you will see that in your institute administration, some people are there who do not really having the expertise in academics field. They have expertise of administration from some other fields, but authority understands that yes, they have that expertise, and by virtue of that, they can lead the administration of the academics. So experience from the other field or other domains is incorporated and involved here. So in multi-level transfer learning, say for example, as I say that a disease, rare disease of kidney and others, and this disease, enough data is not there. So what you can do like that, in sense that from other domain, in which domain there are a large number of data available, even that domain may not have the real link with the liver disease or the kidney disease, that the rare disease problem. So you are having one data in one domain which is far away from other, I mean the actual domain, but you can take initial stage, train your network from there, and then knowledge will transfer to mid-level another network which is having some link with this original domain, and then interface that one, and from there you train your network, and then you make use of that one in your actual problem. So this is basically multi-level transfer learning approaches. Wireless security, as I say, that's very I mean, and in wireless channel very complex and random, and all wireless communication performance to a great extent depends on the knowledge of the channel knowledge. Outdated channel power allocation, the water filling algorithm that you see people use this in wireless communication, people, the power allocation, because my voice is not good enough, you cannot get my signal good, I mean reliably. So in any communication, wireless power is very important issue, and power are having two constraints. For good communication you need to have the high power, but if you use high power your battery drainage will be there, so you are having a trade-off problem, and that power allocation depends on the channel state information or channel condition, and channel state remains, I mean every frequently changes, so outdated. So that is why what is the trend, that recent trend, the machine learning algorithms are used for power allocation to have the knowledge of the channel states, and there are good channel and bad channel and all these which can be made use of this. ITS, intelligent transport system, some of the application I like to say here. Now challenges in the machine learning, of course there is, particularly as I talk about the GAN model, I told there is a stability problem between the generative and discriminator network. Let's say for example, if discriminator network is very powerful, it will always discriminate whatever data is generated by the generator as fake. On the other hand, if discriminator network is very lenient, it will not be able to distinguish any data. So whatever data generator will generate, it will say it is real data. So there is a stability between this. Problem to determine positioning of the objects. Generator network fails to determine the projects. I mean the location of the project is very. So for example, you are having an image having three people and each one having two eyes, so six eyes. So your generator network may generate one person having six eyes. So that's location problem is there. Problem in understanding the perspective, the depth information. So maybe the 2D and I mean you are having a 3D image or like that. So that depth problem maybe. Of course, this is the problem I talk about in the context of conventional GAN, but there are variation of this GAN, particularly the DC GAN and other GANs. They address some of this problem. So this is your data augmentation and reward function in the context of your reinforcement learning. So this is basically the challenges in the context of it. But my summary, what I understand, I mean like to convey you, big CO, the reason of invoking or using machine learning, and always keep your eye and ear open. Observe the day-to-day fact, the phenomena that your surroundings adopt in day-to-day affairs, and many of them will give you the ingredients to develop some techniques, and that may come over in the form of an, because this the way human learn, human behave, that's basically mapping machine. So that's basically the machine learning. Thank you. These are some of the references. Thank you. Thank you. I don't know whether it's at all having any meaning. I think I managed the time. As you say, this 3:30 to 5:30. So I think it's okay. Thank you all.
Thank you, sir. Thank you for your such a ki bolbo, informative lectures. Basically, I also learned something. I don't know this much machine learning, but today's machine learning is a part of our life, and in every aspects, we need machine learning as a part of our research domain. So it's very, very required, and many research topic also I find out from your lectures throughout, that what I can say or I can convey to my students, my scholar, that they can apply on this. Thank you very much, sir. I would like to call Shreya, a student of Computer Science and Engineering 2019 batch, for concluding this session. Shreya, please.
Okay, I can say if anybody has having any question or comment,
Basically,
I will be
this
happy.
is,
I
sir,
would
this
be
is a
happy.
YouTube. Yes, sir. Sir, this is a YouTube live is there. So I think there is some kind of difficulties regarding this.
Okay, okay,
This kind of activities. So, sir, if they have any kind of questions, then I should convey you by through your mail ID, or
okay,
I can give your mail ID to my students also. If they have
okay,
any
okay,
queries, they can
okay,
call.
okay, okay,
Okay.
okay, 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 okay. Then, yeah.
Then please, Shreya, continue.
Thank you, ma'am. On behalf of every student of our college, sir, we are thankful to you. We are very grateful for you coming here, spending your time with us, and imparting such valuable information to us with such simplicity and ease. Because sometimes we get so puzzled with all these statistics, but the way you imparted this knowledge to us was very good. And I have learned a lot, and I would agree with the audience also that they would also agree with me on this part. It's a pleasure to have you here, and we'll try to abide by your rule and suggestion that you said, "De jotota amra pori tototai sigbo." On this note, we would conclude the webinar here. I would
I
request.
don't know whatever words you say, whether it is a real data or fake data. But assuming that it's a real, if it is so, that's okay.
Yes,
Otherwise,
definitely it's
fine.
real.
Thank
Sir.
you so much. Yeah.
Thank you, sir.
Thank
On
you.
this note, we
Yeah.
would
Thank you.
conclude.
So yeah. So, madam, I'm leaving from the meeting. Thank
Yes,
you
sir.
once again.
Thank you.
Yeah.
Again, once
Thank
again,
you.
thank you, sir.
Yeah. Thank you for your invitation, and thank you for thanks for this invitation.
Thank you.
Yeah.
Thank
Bye.
you, sir.
Okay, so we can leave from here now. Thank you all. Akash Dash, Mr. Akash Dash. Akash Dash, are you there? Oh, Abhishek Das, sorry. Abhishek Das. Abhishek, Mr. Abhishek, are you there? Mr. Abhishek? হ্যাঁ, আমাদের হয়ে গেছে, তাহলে ওটা আপনি স্ট্রিমিংটা বন্ধ করে দিন, আমরা তাহলে লিভ করে যাব।